Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So today we'll be talking about linear equation involving the perimeter of a triangle, okay? So please, it's important before you come to this video, make sure you've reviewed the previous video, like how to the distance formula, how to use the Pythagoras theorem, talked about all that in the previous video. So make sure that you've watched all the previous video, okay? And also, if you've not subscribed, I don't know what you're waiting for, make sure you subscribe and also like the video and also click on the notification bell. So when I post new videos, you'll be the first person to know. So when we talk about a perimeter, we're talking about the perimeter of a triangle is basically defined as the sum of all the three sides, okay? So that means if you have a three sides, A, B, C, the perimeter is basically the sum of the three sides. So because I know some of us are writing, make notes from this video, I'm going to write what I just said down. So the perimeter, so when we say the perimeter of a triangle, okay, perimeter of a triangle is defined as the sum of all of its three sides. So that means if I have a triangle like this, let's say I have a triangle A, B, and C, okay? So the perimeter for this triangle now will be that I have to add up each of this together. So the perimeter for this, so I can call the perimeter P, okay, will be equal to the A, B plus C. And that's how you get the perimeter. The perimeter is equal to what? A plus B plus C. So that means in order for you to find the perimeter, that means you must know the three sides, okay? So in order to find the perimeter, you must know the three sides. And how do you do that? So basically, there are some things to keep in mind. So to find the perimeter, okay, so to find the perimeter, the three sides or all the sides of the triangle all sides of the triangle must be known. Okay? So in order to find the perimeter, you must know all the sides of the triangle. All right, so first, one of things is that if, for instance, the coordinates of the 3-point triangles are known, we can then find the sides by using the distance formula. So that means the first thing is that if the coordinates of the three sides or the 3 points of the triangle okay, are known, all right, then the distance can be calculated using, or the sides, let's say the sides of the triangle can be calculated using the distance formula. So for instance, if we have, let's assume this is a triangle, okay? So that means this part here, I know the coordinate to be x1, y1, okay? Then I know this point, the coordinate to be x2, y2, and I know this point as well to be x3, y3. Can you see? Then I can find the distance between these 2 points. Okay, I can find the distance between these 2 points, and I can find the distance between these 2 points. So if you remember, I told you the distance between 2 points is equal to square root of x2 minus x1 squared plus y2 minus y1 what? Squared, all right? So you can now find the distance for each of this. So between these 2 points, so please go back and watch my previous video on how to find distance between 2 points. Okay, so just go back to the playlist. You will see one of the videos we talked about it. So you will now use the formula to get the size for this. Also, the second thing now is that if it was a right angle triangle, we can also use Pythagoras theorem, all right, to determine the third sides if you know the two other sides. So that means if you have a right angle triangle with 2 sides known, you can get a third side using Pythagoras theorem. So if you have a right angle triangle, okay, if you have a right angle triangle, all right, Pythagoras theorem can be applied. Okay, where applicable, to determine the third side. If the two other sides are known. Okay, so if you have a right angle triangle like this, are you seeing it? So for instance, you know one of these sides, or you know this side, or you know this side. So if you know 2 sides out of the 3 sides, you can then apply the Pythagoras theorem, which is c squared is equal to a squared plus b squared. So for instance, let's assume we have a and b. We can find c using this formula. Then when we find c, then you can now find the perimeter, okay? Now, so we've talked about if we know the 3 coordinates of the triangle, okay? Also, we've said if we know it's a right angle triangle, we can use Pythagoras theorem. One other one as well is that if, for instance, it's a scaling triangle, all right, or equilateral triangle or isosceles triangle, something else, we can also use the sine rule or the cosine rule to get the sides, okay? So we can also use the sine rule or cosine rule to get the sides. So if the triangle or if an angle of the triangle is known, if an angle of the triangle is known and some corresponding and some sides, all right? All right. We can use either the sine rule or cosine rule, depending on the information given, okay? So you have to go back to my playlist on trigonometry where we talked about when to use sine rule and cosine rule, okay? So it's very important, all right, to go back and have a look on that. So for the sine rule, you can use sine A over A is equal to sine B over B equal to what? Sine C over what? C. This is the sine rule. You can also use the cosine rule, which is A squared is equal to B squared plus C squared minus 2BC cos A. All right. So you can use either the sine rule or the cosine rule. So if, for instance, you have this, for instance, let's assume we were given this is angle A, this is side A, and this is B and C. Okay, so for instance, you can use this. So if, for instance, A was not given, A was not given, all right, you can use cosine rule to get this angle here. Okay, you can use cosine rule to get the angle here. So the same principle. So if you have to get the angle A here based on using the cosine rule, okay? Or if, for instance, you were only given two sides, let's assume we're given two sides. Maybe you have this angle A and this angle, but you don't have, you only have maybe this angle here, B. You can use sine rule to get this side, and also you can use sine rule to get this other side here, C. So you see, you can use different what? Formulas. So depending on the information you are given, will now determine which to use. So please go back and watch my video on trigonometry, the sine rule and cosine rule, and the rules associated with that. Okay, so now I've shown you how to get the three sides. So when you've gotten the three sides, then you can now apply the rules, okay? You can now apply the three rules on how to find the perimeter. So now at this stage, you've used either it's a right angle triangle, or you have the three coordinates, or you use either the sine rule or the cosine rule to find what? To find the size of the triangle now. So then after that, you then have to apply the three rules to get the perimeter. So the three rules, okay, we're gonna start. The first thing you have to do is that you have to identify, all right? You have to identify the three sides of the triangle. Okay, identify the three sides of the triangle using suitable method. Okay, so like I said, if it's a right angle triangle, if you have an angle and the side, or if it's you have the three coordinates, you find the distance or any other appropriate method. Then when you've done that, number two is that you have to substitute each side into the formula. Okay, so the perimeter is equal to A plus B plus C. Okay, and when you're done, number three, you then what? You simplify. Okay, so the first thing, you identify the three sides of the triangle using suitable method. The second thing, you then substitute each side into the formula. And the third thing is then you then what? You then simplify. All right, good. So I'm going to pick an example now, okay, so that I will use it to explain. So let's say we have this question here. They said, given that line PQ intersects the coordinate axis. So when we say coordinates, so it means the X and Y. Is that okay? So you can say the coordinate axis, so X and Y axis at, we have 0, 4 and 3, 0. The question now said, find the perimeter of triangle OPQ, right? So identify the three sides, okay? So identify the three sides of the triangle. So in some cases, you might be you can just sketch if need be, okay? So you can add that. So you can sketch if need be. So for some students, they'll prefer to sketch so that they can see the diagram and make it be easier for them to work with, all right? So what I'm going to do in this example, I'll try and sketch it. So we have a line PQ intersect. So let's draw this. So step one, let's have the X and Y axis. This is the Y axis. This is the X axis. And we're told that the intersection is at where? The intersection is at 0 and 4. So this is X and Y. X is 0, Y is 4. So let's put it here. X is 0, Y is 4. So let's call this line P, 0 and 4. And X is 3, Y is 0. X is 3, Y is 0. So let's call this Q. Okay? So that means this is the line they are referring to. So they said this is the line. But they say find the perimeter of OPQ. So O, this is O here. Are you seeing it? The origin. So you can see there's a triangle now, O, P, and Q. So this is the triangle that we're going to look for the perimeter now. Okay? So that means we know now that this is the origin. And what the coordinates of the origin? Origin is always 0 and 0. So please go back to the coordinate system. If you've missed that video, one of the things I talked about for coordinate system was for origin. The coordinates for origin is 0 and 0. So that means I can easily say for this, the origin is 0, 0. The P is 0 and 4. And the Q is what? 3 and 0. All right. So what we can do now is that we can then use the distance formula to find this. Okay. So we can use the distance formula now to find this. So let's go. We'll separate this now. So let's go. So we're going to use distance formula. So we're going to start with OP. Let's find distance between O and P. So remember I told you, if you have the 3 vertices known, all right, 3 points, or the vertices or the coordinates are known, we can use the distance formula to find the sides. Okay, so let's go. So we have the 3 vertices. So we're going to start with OP first. So this is OP, this part here. Okay, so let's go. OP, we know the formula. So we know that the P and O. So we're looking for OP here. So we have the O is 0 and 0. And the P is what? 0 and what? 4. Are you seeing it? Good. Then we use the distance formula. We know that the distance is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So from this point, we know that this is our x1, y1, x2, y2. So that will give us square root of x2 will be 0 minus x1, 0 squared, plus y2 will be 4 minus 0 squared. And the distance for POP is going to be what? Will be equal to 4. So that means the distance here is equal to what? 4. The next one, we can find OQ. OQ. So we have this, O and Q. Then the OQ, we know is this time we're going to be using O and Q. So we have O to be 0 and 0. We have Q to be 3 and 0. So we know the distance formula for this is equal to the square root of x2 minus x1 squared plus y2 minus y1 all squared. And that will give us, this is our x1, this is our y1, this is our x2, this is our y2. And that will give us the square root of x2, 3 minus 0 squared plus y2, 0 minus 0 squared. And that will give us, which is the OQ. Okay, so our OQ now is going to be 9 square roots will give us 3. So that means the distance for this one is what? 3. So that means OP is 4. OQ is now what? 3. The next one we're going to find now, we're going to find PQ, the distance for PQ. So we have PQ. So for PQ now, because this is a right angle triangle, we can use Pythagoras, okay? We can use Pythagoras to find this, but because of I just want to be consistent with the same formula, I'm going to still use the distance formula to find this, okay? So we're looking for P and Q. So P is 0, 4. Q is what? 3, 0. Okay? So let's go. We know the distance formula is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. This is our x1, y1, x2, y2. They'll put it in the formula. The distance is going to be equal to square root of x2 with 3 minus 0 squared plus y2, 0 minus 4 what? Squared. And this will give you 9 plus 16. That will be 25. Square root of 25 will give you what? 5. So therefore, PQ is equal to 5. Equal to 5. So then, with this now, we can go to step 2. I can draw this triangle again to make it clearer. OP, this is 4. PQ, this is 5. So this is OPQ. And OQ, it is what? 3. Can you see? We've seen the distance for 3 of them. So, but step 2 now said that we should substitute each side into the formula P is equal to A plus B plus C. Okay? So let's go. So we know P is equal to A plus B plus C. And we know the sides we're having here is 3, 4, and 5. So it's going to give us the perimeter will be 3 plus 4 plus 5. And that will give you what? 12. So step 3, the perimeter for this question, the perimeter will be equal to what? 12. And that will be the answer for that. Okay? And that will be the answer for that. So we're going to pick another example now. We'll go straight to another example. All right, let's solve another example. So let's pick another example here. Example 2. So we have a question here that said the line T has the equation 5x minus 6y minus 30 is equal to 0. Number 1, find the coordinates of P and Q, where line T crosses the coordinate axis. Okay? And number 2, we're meant to then find the perimeter of the triangle OPQ, where O is the origin. Okay. All right. So the first question now said we should find the coordinates of P and Q where the line T crosses the axis. All right. So the first thing to do, so for it to cross the axis, coordinate axis. So remember I told you coordinate axis means X and Y axis. So I've talked about this before, that when it crosses the x-axis is the x-intercept, and at x-intercept y is equal to 0. Where it crosses the y-axis is the y-intercept, and at the y-intercept x is equal to 0. So I'm going to quickly jump into it. So we have at x-intercept, okay, at x-intercept, y will be equal to what? 0. So we'll go back to the equation there. We have 5x minus, but anywhere we see y, we put 0. We'll give you my 6, 0, minus 30 equal to 0. This will give you 0, so it's going to give us 5x minus 30 is equal to what? 0. Take 30 to the other side, okay? So it's going to give us 5x is equal to 30. Then divide both sides by 5. So therefore, x will be equal to what? 6. So we can then write this correctly as the coordinates. It will be what? X is 6 and y is what? 0. All right, please, if you missed my video on X and Y intercept, okay, please go back and have a look at that video. So that is that for X intercept. The next one we're going to find is at Y intercept. So at y-intercept, we know that what? X is equal to what? 0. So we go back, we have this, but anywhere you see x, you put 0. So it's going to be 5x minus 6y minus 30. So it's going to be 5 into bracket 0 minus 6y minus 30 is equal to 0. So because anywhere we see x, we're going to put 0 because at y-intercept. So this will give you 0. We're going to have minus 6y minus 30 is equal to 0. Take 30 to the other side. Minus 6y is equal to 30. Divide both sides by minus 6. Divide both sides by minus 6. Therefore, y will be equal to what? Minus 5. So now we can put this in a coordinate form. At y-intercept, x is 0 and y is what? Minus 5. Then, with this, with the knowledge of this now, we can then sketch the graph. Okay, we can sketch the graph. Okay, so we have O, the y-intercept is occurring at 0 and minus 5. So let's assume this point here is minus 5. Okay, so we have the point Q. Then the other one, the x-intercept, which is the point P. Okay, so this is point P, and this is going to be point Q. Okay, so point P is at 6 and 0. So this is point P here. So P is 6 and 0. Okay, so this is the line that we're drawing for this. Okay, and we're also told that this forms a triangle OPQ. Can you see? So if you look at this, there's a triangle here, O, P, and Q. So you can see this is the triangle the question was referring to. All right. So the question wants us to then find the perimeter for O, P, and what? Q. So let's start. All right, let's start. So what's the first thing to do? The first thing, since we know the coordinates of P, okay, we know the coordinates of P to be 6 and 0. We know the coordinates of Q to be 0 and what? -5. Okay? And we know the coordinates of the origin. Like I told you, the origin is 0 and 0. 0 and 0. We can use the distance formula to find the value for each of these ones. Okay? We can use the distance formula for this. So we're going to use the distance formula to find each of this. So I'm going to first start with OQ. Okay? I'm going to find the each distance formula here to find OQ. All right, so let's go. So we're looking for the distance OQ. So we know our O, okay? The O is the origin, which is 0 and 0. And our Q is what? 0 and -5. So Q is 0 and what? -5. Okay? So as usual, we know this is our x1, y1, x2, y2. Then we can find the distance. The distance is square root of x2 minus x1 squared plus y2 minus y1 what? Squared. And that will give us the distance will be equal to square root of 0 minus 0 squared plus y2 is -5 minus 0 all squared. And this will give you square root of 0 plus 5 squared, that is 25. Square root of 25 will give you 5. So that means OQ is equal to 5. So that means I can easily say that the OQ here is what? 5. The next one, I can get OP. Okay, so I'm going to get OP now. So we're going to look for OP, the distance. So we have OP, and that will give us the O, the origin, and the P is 6 and 0. Okay, the origin 6 and 0. So like you know, this is going to be x1, y1, x2, y2. Okay, so then we can now find the distance. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 all squared. Then the distance is going to be equal to square root of, my x2 is 6 minus 0 all squared plus my y2 is 0 minus 0 all squared. Then my distance will be equal to 6 squared, that will be 36. 36 plus 0, 36. Square root of 36 will give you what? 6. So now I can easily say that my OP here is equal to what? 6. Now I can find QP, all right? QP, next one. I'm going to find QP. Now for QP, because QP is a OPQ is a right angle triangle. So that means I'm already having a triangle like this now. Okay, I know here to be 6, and I know here to be 5. So I can find my PQ now, or QP, using Pythagoras theorem. All right, so I don't need to use distance formula, because if it's a right angle triangle, remember I told you, if it's a right angle triangle, Pythagoras theorem can be applied where applicable to determine the third side if the two other sides are known. All right, so I can apply that here because in this case here, I know the two sides, so I can get a third side, which is this, C. Okay? So I can apply Pythagoras, which we know that Pythagoras, the A we have here is what? The A is 5. The B is what? 6. And we're looking for what? C. We know the formula, C squared is equal to A squared plus B squared, which will be equal to 5 squared plus 6 squared equal to C squared. Then C is going to be equal to the square root of 5 squared plus 6 squared. And that will give us square root of what? 61. So the C is equal to square root of 61. So the answer here is going to be square root, which is PQ or QP, will be equal to square root of 61. So that means C here is equal to square root of what? 61. If you want as well, you can use the distance formula. You still get the same thing. So any method you want to use, feel free to use, but you can only use Pythagoras if it's a right angle triangle, okay? So now, with this, now we can jump straight to step 2, okay? Step 2, we know that the perimeter is equal to A plus B plus C, all right? I already know this, like this already. We know that the size is 5, 6, and root 61, okay? So 5, 6, and root 61. So that means the perimeter is going to be equal to 6 plus 5 plus root 61. And that will give us 11 plus root 61. So step 3, we can now say the perimeter for this is equal to 11 plus root 61. So it's 11 plus root 61. All right. I'll pick one more example just to throw it in there. Then I will go to the next topic on area. I'll pick one more example just to explain this concept one more time. All right, let's pick another example here to just round up this concept, okay? I have this question here. They said the corners of a triangle. Okay, are the points A, we have 6 and 9. Then B, we have -2 and 7. And C is at 5 and -8. The question now said, find the perimeter of triangle ABC. Okay? So like I told you, step 1, if you want to, you can sketch it if you want to, so that you can have a good picture about it. But you can just quickly you can plot it if you want to, but sketching it should be fine. Okay, so I'm gonna just sketch this, but not to scale. So this is, let me call this A. Okay, so point A, we have point A 6 and 9. Then point, let's say to point C. So remember, this is not drawn to scale, okay? Let's say point C, we are having it at 5 and -8. And point B, we're having point B at -2 and 7, okay? So this is the triangle A, B, and C, all right? Triangle A, B, and C. All right, so having something like this, we've sketched this out. So the next thing that we need to find as well is we need to find the distance for each and every one of them. So remember that this is not to scale, or it's just a rough sketch. So this is going to give us for AC, okay? This is going to give us for BC, and this is going to give us for AB, all right? So let's go. Let's try this. So let's start. I'm going to start for AC first. So for AC, we know the A is 6 and 9, okay? And we know for the C is 5 and -8. So this is the X1, Y1, X2, Y2. So we'll put it in the formula. The distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Then the distance is going to be equal to square root of x2 will be 5 minus 6 squared plus y2 will be minus 8 minus 9 all squared. And when you press this in your calculator, this should give you square root of 290. Okay? So that means for AC, we can say AC is equal to square root of what? 290. Then let's go for the next one, BC. Let's go for BC now. So the distance for BC will be equal to, we know the B is minus 2, 7, and the C is 5 minus 8. So this is x1, y1, x2, y2, okay? So that means the distance is going to be equal to square root of x2 minus x1 squared plus y2 minus y1 all squared. So this is going to give us equal to square root of x2, which is 5, minus x1, which is minus 2, all squared, plus y2 is minus 8 minus y1, which is 7, all squared. And when you press your calculator for this, it should give you square root of 274. So that means I can now say my BC is equal to what? Square root of 274. Now the next one I'm going to do now is the AB. AB, so what's the A? The A is what? 6 and 9. And the B is minus 2 and 7. So 6 and 9 minus 2 and 7. So this would be my x1, my y1, my x2, my y2. Okay? So the distance is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 all squared. Okay? And that will give us equal to the square root of x2 be minus 2 minus 6 all squared plus the y2 will be 7 minus 9 all what? Squared. And when you press this in your calculator for AB, the answer you will get will be 2 root 17. So AB here is going to be equal to 2 root 17. All right? So now we can draw this again. The triangle, just to be clear. So we have A, B, and C. We said our AC was square root of 290. Our BC square root of 274, just to be sure. Yes, and the AB was 2 root 17. Equal to 2 root what? 17. All right. So step 2 now, we can find the perimeter. The perimeter is equal to A plus B plus C. And that will give us square root of 290 plus 2 root 17 plus root 274. And step 3, and that will be the answer for that. You can simplify this further. All right, so please, if you've forgotten the rules of sorts, so remember I told you the only time you can add sorts together, C root B, is only if they have the same sort. So like in this case, it's going to be A plus C or root B, okay? But if you're having A root B plus C root D, you can add it. You leave it like that, okay? So that means the perimeter for this, step 3, the perimeter for that will be equal to, okay, root 290 plus 2 root 17 plus root 274. And that will be the answer for that. All right, so that'll bring us to the end for this, how to find perimeter, okay, related with linear equation, all right? So we're going to go straight to the next one. We're going to talk about linear equation involving area of a triangle, all right? We'll see how do we then use, how do we find area of this triangle? Now we found only the perimeter, which was basically easy. You just need to find the sides, the 3 sides, and then you move on from there. But what about if you have a triangle now and you are now told now to find the area? How do you go about it? Okay, so that'll be the next video. And please, like I always say, if you've not subscribed, please do so that when I upload new videos, you'll be the first person to know. All right, so I'm going to see you soon in the next video. And please don't forget to subscribe and click the notification bell. So when I upload, you'll be the first person to know. So see you soon.